This is Geometry, Part 2 to the 12.1, 12.3 review. We left off Part 1 working on number 6 and looking at the area of the Pentagonal Prism. And we left off with finding the area of the Pentagon. So now we want to work on the surface area equals 2 times the base plus the perimeter times the height. So our base is 39.03. The perimeter would be 5 times 5, and the height would be 6. So with this, we take our 39.03 and times it by 2. 78.06, and we take our 5 times 5 times 6, which is our 150, and add those two together. So we got 228.06, and those would be centimeters squared. That should close off number 6. So let's come back and take a look at some of these others. These are now cylinders. And we're going to find the surface area. The surface area, remember, is 2 times pi r squared, because there are 2 circles, plus the circumference, 2 pi r, times the height. Well, if we know what the radius is and we know what the height is, then 25 gets plugged in here and we get 25, or the 5 gets plugged in here to get 5 times 5 is 25 times 2 is 50. So we have 50 pi plus 10 pi h. And our h is 15. So that's 50 pi plus 150 pi. That leaves us with 200 pi as our surface area. So 200 times the pi, which is 3.14, gives us 628.31 centimeters squared. This next one, same idea. We take our surface area formula and 2 times 2.1, or 1.1. We do 1.1 squared and times that by 2. We're going to get 2.42 pi, and we're going to have 2 times the radius times the height. And that's 7.04. So that should be 9.46 pi. And when we times our number by pi, we get 53.52. And those are feet squared. Well, we got a 9.46 pi. That part looks right, but I'm not sure where the 53. We should get 29, because 9 times 3 is 27. So 3.14 is going to be a little bit extra. So my number just didn't make sense. And that was feet squared. So that surface area looks a little bit better. The next circled one here, it Looks like another rectangular prism. Looks pretty much like a cube, but not quite. 8 for the height, 6 for the depth. we're trying to find out our distance for our width. So we know our surface area equals 2 times the base plus the perimeter times the height. That's one way to do it. Another way to do it is to calculate out the front, the back, the right, the left, the top, and the bottom. But if we know our surface area is 320 and our base is 2 times 6 times x, our perimeter is 6 plus x plus 6 plus x. So that's 12 plus 2x that is our perimeter there times the height. So now we're going to have 320 equals 12x plus, notice you cannot call that 14x. These are unlike terms. We can distribute this through to get 96 plus 16x. That looks a little bit better. Subtract our 96 from the other side to get 224. We have 28x, and our 224 should be divisible by 28 8 times. So our x is 8. Our missing side would be 8 meters. For number 11, we have our rectangular or a triangular prism. So let's first start off this with the Pythagorean Theorem. 4 squared plus 6 squared is going to equal the hypotenuse squared. So it gets 36 and 16. That equals our hypotenuse squared. Add those two numbers together. We get 52 equals our hypotenuse squared. So the hypotenuse is the square root of 15. Properly placed right where it's at. So now, the square root of 52 is going to be a little bit larger than 7. So we get 7.21. So when we do our formula, that is 2 times the base. So we're 2 times, oh, and look at that. We don't really need that value. That was fun to find anyway. Because here's our right angle. It'll be helpful in our perimeter, I guess. 2 times half base times height. So the base and height I'm referring to at the moment is just this 4 and 6. They're perpendicular to each other. So the 2 and the half are going to cross off, and we're going to get 24. And we're going to add that to the perimeter. And the perimeter is going to be 4 plus 6 plus our 7.21 gives us 1721. And times that to the height, which is unknown. So that should be our surface area of 200. Now you cannot add the 24 to the 17. You've got to subtract the 24. That's going to give us 176 equals 1721. And we'll divide it by that value, and we'll get 10.13. Or 10.23. It'll be x there, so x equals, because we divided it in. So we found out what the height would have been to get us as close to 200 as we can. Number 12. For number 12, we're looking at our cylinder with a radius of 8 and a height of an unknown with a surface area of 1,000. So we're going to take the surface area equals 2 pi r squared, because it's twice the base, plus the circumference, 2 pi r times the height. So we've got 8 as our radius. So 2 pi 8 squared plus 2 pi 8 times x gives us 64, which is 128 pi. This gives us 16 pi times x equals 1,000. Well, these are unlike terms still, because this has the x. So I can subtract 128 pi. So I got to figure out what 128 pi is. And that's going to come out to 402.12. So take that and subtract that from 1,000, and we'll get our 597.88 equals 16 pi x. Now we're going to divide both sides by 16 pi. You need to be sure that your calculator divides that correctly. And we get 11.89. So that would be the height of this cylinder. And checking my answer using the calculator, it comes out pretty close to 999.78. And that's because we were using rounded numbers. It does not come out exactly when you use rounded numbers, but that's a pretty accurate estimate for us. So we got x to equal 11.89. Those were centimeters. $11.89. This was number 11. This is number 10. So let's look at number 18. The radius of a cylinder. Find the radius of a right cylinder with a surface area of 48 pi whose height is 5. Well, it really helps if you draw your picture. Just a basic idea. Find the radius, that's what we don't know. If the height is 5 and the surface area is going to be 48 48 pi. Now notice how it has the pi symbol in it. It's going to make the problem a lot easier to work with. So we're going to say 48 pi equals 2 pi r squared plus 2 pi r times 5. Interesting. So now what we're going to do, we can divide everything by 2 pi. That would be one way to get rid of all of these 2 pi's. We get 24 that equals r squared plus r times 5. And actually, the only way to solve this one is r squared plus 5r. We're going to bring the negative 24 across, so it equals 0 on the other side. We haven't done this since algebra class, but you would need to factor this one apart. Don't stress yourself out about the factoring. So a positive 8 and a negative 3 is the way you would factor that. You're looking for two numbers to multiply to be negative 24 that add to be positive 5. You might remember that from your algebra days. So r is going to either equal negative 8 or it's going to equal positive 3. And of course, for geometry, we can't have a negative 8, so we'll rule that one out. And we have our answer of positive 3. Okay, our last one, number 15, kind of turns sideways here. Last one for this section, at least. What we have is a surface area. We have a triangular prism. And we know that we have bases of 5, 5, and the back side is 6, and the height is 10. We're looking for the surface area. So that means is we need to find the area of the base. Because remember, to calculate this out, surface area equals 2 times the base plus the perimeter times the height. Well, the base is 5, 5 with a 6. Well, we're going to cut that exactly in half. We practice this a lot in class. So this is this triangle that we're looking at here. That would be half the triangle of the base. So if you have one side of 3 and a hypotenuse of 5, what's the missing side? It's not a 30, 60, 90 triangle. There's not enough information to show that. But you might notice that you can use Pythagorean Theorem, or you could even use a Pythagorean triple. What's the height of the triangle? That's right, it's going to be 4. You could do that saying 5 squared equals x squared plus 3 squared, and it would solve out to be 16, and the square root of 16 is 4. So we know that this triangle is 4 times 3. Half of 4 times 3 is 6, and there's 2 of them, so we get 12. We get 2 times the half of 4 times 3. The perimeter is 16, and our height is 10. So we're going to get 12 plus 160, we get 172. These are inches squared. Now we flipped over to the back side, and we're looking at section 12.3. We have the circled ones to work on. Notice that this one gives us the slant height. So we know that the formula is going to be surface area equals the base plus half the perimeter times the slant height. So the area of the base, this is a regular pyramid, so that means that the base has all the same side lengths. So 4 and 4 makes 16. Half the perimeter is 4 plus 4 plus 4 plus 4. So that's also 16. And the slant height is 6. So we get 16 plus 48, which is 64 meters squared. So here they're giving us the actual height of the triangle. We need to figure out what the slant height of the triangle is. So we're looking at a right triangle with a length of 11 and a height of 8. We'll use Pythagorean Theorem to figure out our slant height. The slant height squared is going to equal 11 squared plus 18 squared. So our 11 squared is going to equal 121, and our 18 squared is going to equal 324. We add those two numbers together to get 445, and the slant height is going to be the square root of 445. So our area, surface area, is going to be the base plus half the perimeter times the slant height. Well, the base is 22 times 22. Comes out to 484. And we know our perimeter is going to be 22 plus 22, which is 44, plus 22 plus 22, which is 88. Half of 88 is 44. Square root of 445. And we times that together. And we come up with 1,412.18. And those are centimeters squared. Here we have a regular pyramid. Same idea. Well, let's take a quick look up here. Here they actually wanted each lateral face. So each lateral face would not have been that whole calculation. Each lateral face would have been half 4 times 6. Would have been 12. That would have been the actual lateral face. And over here it would have been half of 22 times the square root of 445. So 11 times the square root of 445. And we get 232.05. That would have been the lateral face. One lateral face, one side of the pyramid. Here they want us to use the whole pyramid. So back to that formula, which would be 7 squared plus half the perimeter, which is 28, times the slant height. 49 plus 140, which is 189. These are meters squared. This next one, notice that the base is a pentagon. So if we take the hexagon, and the hexagon is 9 there, it's also going to be 9 here, which makes this an equilateral triangle, all of 9. So when we cut it in half, we're going to get to 4.5 and 4.5 root 3. So that's helping us calculate the area of this pentagon. 4.5 times 4.5 square root 3. We get 3507. .5, which is when we cut the 9 in half, and the long leg, this is a 30, 60, 90 triangle, so we multiply the short leg by root 3 to get 4.5 root 3. Length times width divided by 2, because it's a triangle. And by timesing that by 2, we're going to get 3507. So now that's the area of the whole triangle times 6 of them. Gives us 210.44. That's the base. Now we can go ahead and find out the rest of the formula, or use the rest of the formula. We've got 210.44 plus half the perimeter, which is 9 times 6, which is 54, times the slant height, which is 14. So 27 times 14 is 378. 378 plus the 210.44 gives us 588.44. And that's for number 5. Next, we're going to look for the lateral side of our cones. The lateral side of our cones we're using our formula for surface area, and that the whole surface area, remember, was pi r squared plus 2 pi r oops, sorry, which is actually half of the circumference times the slant height, just like the perimeter times the slant height. Well, half of 2 always crosses off, so we get pi r squared plus pi rl. Well, we're just looking for the lateral, so we're just looking for that part of our formula. So pi times 5 times 10, we get 50 pi. If we have 50 pi, that's 50 times 3.14. Well, we're going to use the pi button. We get 157.08 meters squared. That's the area of the side, not including the base. So for this one, we have our Pythagorean Theorem, which would give us a slant height of 10. 6 and 8 still are in that same pattern of 3, 4, 5. 3, 4, 5. 3 times 2, 4 times 2, 5 times 2. So the hypotenuse of this right triangle is 10. That's the slant height. So we're doing pi times r times the slant height. The radius is 6. The slant height is 10. So we got 60 pi. Got 188.50 feet squared. Now for number 10, we're going to look for the entire surface area. So we go up to that formula and we say pi r squared plus pi r times the slant height. 64 pi plus 8 times 15, 120. It gives us 184 pi. That's the exact answer. So that comes out to be 578.05. Those are meters squared. For this one, the radius is 7. We still need to know what the slant height is. So we have 7 squared plus 11 squared equals the slant height squared. We got 170 equals L squared. So the square root of 170 is our slant height. So we'll be able to say pi times the radius, which is 7 squared, plus pi times the radius times the slant height. Notice how I use the exact answer so I don't come up with a problem. So we'll say pi times 7 squared plus pi times 7 times the square root of 170. 440.67. Those are feet squared. Now here, these are called composites when you're taking two items together. Here we have the lateral of a pyramid and the lateral with one base of a cube. So what we have, the base is going to be 8 times 8. The lateral face is going to be the perimeter, which is 32 times the height, plus we're going to add the top on, which is half the perimeter, which is 32, times the slant height, which is 10. 64. We have 32 times 8, which is 256, plus half of 32 times 10, which gives us 160. That's given us 480 meters squared. It's the area of the base plus the area of the sides plus the area of the lateral faces of the pyramid. Same idea here. We're going to take the pi r squared plus we're going to take the 2 pi r times the height of our cylinder plus we're going to take the pi r l for the cone. So our radius is 2. So we have 2 squared plus 2 pi 2 times the height, which is 5 of our cylinder, plus pi times 2 times the slant height, which is 7. So 4 pi plus 20 pi plus 14 pi, 38 pi. And then looking for the exact, or that's the exact value, and a rounded number, 119.38 inches squared. So what did I do? I found the area of the circular base, I found the area of the lateral side of the cylinder, plus I found the lateral side of the cone. Using the formulas we've been discussing, these are two added together. Of course, we don't have to find the base of the cone, or we don't have to find the second base of the cylinder, since this pointed shape, kind of like a missile or a pen or a pencil, you wouldn't be covering that extra circle. Good luck.